This conference will now be recorded.
I'm at the Norcross, Georgia facility this morning. And what we want to do is talk to you about the splicing of rollable ribbon. Not too long ago, ribbon or any ribbon fiber pretty much came in one flavor. It was 250 flat. Every splicer could splice it. And then came our rollables, pliables, spider, still in 250s pitch. All splicers could pretty much handle it. With a few changes to the fiber holders and the thermal stripper. And then came the 200 rollables. This changed the game. You cannot load 200 ribbon into a 250 machine without some type of pitch conversion or making a semi-permanent change to the machine by sending it in to a shop like mine, if it's a Fitel, for a V-groove and holder change. And then you're stuck with a 200 ribbon splicing machine, or you have to buy an additional machine, one for 200 and one for 250. So that's when we were talking to S&S about this presentation that we've been doing for a lot of our clients, and thought we'd go ahead and share it with you. Everybody can see the presentation okay, I hope?
Yep, you're looking good.
Okay, so we'll go into the rollable ribbon and splicing solutions. This is a fishbone diagram we developed. If you look at this for the whole total splicing solution, there's a lot that goes into it. It's just not just a fusion splicer. You got to, over here, you got to have a good cleaver that can handle these different type of ribbons. The thermal stripper is very important also. Fiber holders to make sure that the fiber doesn't slip, because you're dealing with thinner ribbons at this point. And even down to the protection sleeve. We have developed what we call an S124, and we'll show that to you later in the presentation, that actually helps separate the fibers in a rollable matrix when it shrinks. And you can see pretty much the players here on the left-hand side, the ribbon design makers. Of course, we have Fujikura AFL, Sumitomo, OFS, Prismium, and Corning. And then we're dealing with all different types of fiber ribbon sizes, 250 and 200, 4 ribbons, 8, 12, 16, and we're even going to be going to 80s for special, not mainly for telecommunications, but for more component pieces, but 80 micron ribbon is also going to be available. So like I said, you got your flat and rollables, and all this has got to come together, and you got to have one good package to be able to handle all this, you know, one time, no matter what type of field splicing situation that you get into. We want to show you some of the structures by vendors, so you kind of understand what you're dealing with out there if you haven't seen them already. In the upper left-hand corner here, you'll see the OFS, Furukawa, who owns OFS, also known as FEC. Our type of structure, it's pretty much just a either 200 or 250 coated fiber with different bonding points, adhesive, and it makes it very, very flat. Ours is probably one of the flattest and thinnest on the market because there's no bonding point. And then we've got Fujikura. They do not have they have a 200, but what they do is they pitch it out. If you see here in the bottom, they put more material in between the fibers to actually pitch it out, so you can use that on their 250 pitch fusion splicers. So, and they also, of course, have a 250. They still have a matrix on it. Their design is a little bit different. And Eric, I believe you were saying that Prismium, I'm not that familiar with Prismium, it's more like the Fujikuras, I believe. Is that right?
Yeah, I think the flex ribbon has more of a matrix as well, but it does not pitch it to the 200 isn't pitched out. I believe it's, I don't know, it almost looks, and I'd have to ask the engineers there specifically, but yeah, it looks, that sounds somewhere in between the two. It's in the upper right-hand corner, but similar.
Okay. Yeah, this what we have on the right-hand side is Sumitomo. It's a really different structure. They go, they bond like 2 fibers. It is a, I think that is full matrix on the Sumitomo, but when they process it, they like slice it. They have some type of blades that slice it, and they come out into this structure of 2 fibers times 6 matrix. So it's a lot different. So just gives you an idea. When we had the 250 flat ribbon, it was all pretty much the same. You know, you had your 250 fibers and you had the matrix bonding on top and bottom. The world has totally changed now with going into these rollables, pliables, spiders, whatever you want to call them. So just want to let you be aware of the different type of fibers that you'll see out there. So our solution is actually to have a splicer that can handle both 200 and 250 pitch. We'll get into this more in detail, but this is our new S124 M12. And this big V groove you see in the side, it's actually removable out in the field. You don't have to send it back to me. You don't have to send it back to the shop. You can actually, with one screw here, you take your electrodes out. With this one screw, you take it out and you've got 250. Then you can replace it with a 200, change your program, and keep splicing. So our idea was to have this exchangeable V groove so that you can go out in the field, pretty much any type of ribbon situation, either flat, rollable, anything that you can pretty much splice anything that's out in the field. We developed this removable V groove technology and patented that with our Ninja. I don't know if anybody's familiar with that, but that's just our little fiber to the home machine. It was a great idea. It was very helpful. You could pull that V groove out and clean it, which is the biggest maintenance problem on a fixed V groove machine. So it was very important with that. And then we migrated that technology to our S179. Again, you can't pull out both V grooves on a core alignment machine. The right one is your alignment, but you could pull the whole left one out. It was pretty much everything but this section right here. But what that made it very easy to do is access your optics, your lenses, very easy to maintain and clean, so you can keep this machine out in the field and not send it back to us. So those two, that was great, but the most impactful removable V groove we've got right now is the S124, since you can change from different pitches, 200 to 250. Pretty soon we're going to be introducing a 16 fiber, pretty much for data centers, for ribbon, and that'll be coming soon, and also with the 80 micron that I was talking about. Here are some of the other tools that go along with this. Like we said at the beginning, and on that fishbone diagram, you got to have a complete package to make sure everything works correctly. If you have a splicer works great, but your cleaver doesn't work great, you got a bad operation there. So what we did is we took our 326A and made some additions to it. You really can't see it in this picture, but right here there's a little press mechanism. So when you load the holder into the cleaver, it actually references it on this 90-degree here to make sure your fibers are going to be nice and straight. Very, very important when doing ribbon fiber. You don't want to get, if your fibers are cleaved on an angle and they're not the same length, you're going to get gap errors and poor splicing. So that really helped out tremendously. And then we used a, believe it or not, just an anti-static coating on the trash bin. And that helps out to keep the fibers from balling up on a exit roller here when they get static on them. So that was huge. Try to keep the operation a little bit cleaner. And of course, we got a sharper blade with it. And this blade on this one, on the 326R, is actually removable. We listened to our customers. On our A model, it's not removable, but on the R model, you can remove it. And then we'll go down to the stripper. That was another item I was talking about earlier. It's very important. Is the thermal stripper here, the S218R 200. It is backward compatible with all the different ribbons that are out there, the 250 flat, 200 flats, 200 rollable, 250 rollable. So we improved the heating element, the thermal contact, and then also the blades were more optimized, so they're a little bit more intrusive since the fibers are a little bit thinner. So we took great care in that, and everybody is just loving this thermal stripper. A lot easier to use. Along with that, again, we had to do something with our fiber holders, the ribbon holders here. We had to make the rubber pad height, we had to make it a little bit thicker too, so they grip onto that fiber, and add more magnets to it, so we had more of a clamping force. Because what would happen using this in conjunction with a 218, if you weren't putting a real tight grip on it, the fiber would actually slip on you. So we had to make sure that we took care of that. We'll talk about this more in detail, but this is a pitch conversion holder. If you're getting into a situation where you have to go, I don't care if whose machine or whatever you're out there in the field, if you're splicing a 200 to 250, like on our machine, yeah, great, we got the removable V grooves, but you'd still have to use like the 200 pitch V groove. You can't pitch down, you have to pitch up from like 200 to 250, and you'd have to use something like this that'll transform it from 200 pitch and out to 250 pitch so you could still splice it. So we'll talk about that a little bit more in detail. And I mentioned the S124, the sleeve. As you can see, the structure here, the structure rod is actually turned upside down, and it allows, when this melts, it actually separates the fibers. So you don't get any type of crossovers, micro bends, which can give you high dB loss. So something that small can really affect your splicing results, and we took all that in mind. Like I said, from the splicer all the way down to even the protection sleeves. As far as time is concerned, what we tried to do is compare everything to 250 flat ribbon. We've got this down really significantly to a point where it's not too far from prepping 250 flat ribbon. I would say probably one of the biggest things that you have to do, it takes up a little bit more time, is we recommend brushing out the splice coating every time you use like the thermal stripper. Instead of like on flat ribbon, you'd normally come out in one big piece of matrix material. This comes out in individual pieces, and you have to brush that out to make sure that the blades are clean, and that takes up a little bit more time. In loading it, you got to take a little bit more care, but the time difference really isn't that far off. We developed this little splicer compatibility for rollable. I won't go through every one of these, but this is something that you really got to be aware of when you bid for a job and you take a job on, to make sure that you got the right equipment for that. Make sure that your machine will work on that particular cable. Like for our OFS 200 rollable ribbon, Fujikura really doesn't have a solution for that. They have a pitch conversion, but remember, pitch conversion, that's great that you can get it done, but a lot of these jobs are time. Time is money. So it does add, an extra minute to a minute and a half sometimes per side to get that pitched out. So like I said, you can have this presentation for your reference, but like I said, I won't go through every one of these, but just really make sure when you're doing this that you understand the structure like Sumitomo's, of Fujikura, of the Prismium, and what machines will work with that, and make sure that you have the right equipment. And down here we also have a little chart for you here for pitch conversion. We do have a pitch conversion holder. I know Fujikura does. Sumitomo, their pitch conversion, I think, is mainly for their fiber and their machine. So we don't know a whole lot about that, but I don't think it'll work for our OFS ribbon and Fujikura ribbon. So there are some question marks there. And also if Fujikura's will work for the Sumitomo ribbon. But still, these things are things that you really got to understand and know before you take a job on, bid a job, that you make sure you have the right equipment. And what we'll do is go through a basic mass fusion splicer review. I won't get too detailed in this. I think most of you have a lot of experience with this, but just basically how the splice is working and the different elements and what's really important to make up a good mass fusion splice. Of course, you can't have 12 different alignment mechanisms here. So the alignment method is passive. You got basically a V groove. Ours is a ceramic V groove, and you got these micro V grooves, high precision V grooves cut in there. And that's pretty much all that's being used to do the alignment. A fiber clamp comes down, sits on top of the fibers, and you're pretty much just pushing fibers together. We have a couple of different methods of helping the alignment if it's not right. We have a couple motors that'll actually come up and take the fiber clamps up and reseat them, and a lot of times just reseating them will get your axis offsets down. But basically it all comes down, it's a fixed V-groove machine. That's why you got to really make sure those V-grooves are clean. If you can see a piece of dust in that V-groove, I think it's got to be at least 30 to 40 microns if you got good vision, and you understand that 3 to 5 microns in that V-groove can really set the axis offset off and really increase your loss. So it's very, very important to keep everything clean on these things. But then again, right here, it's pretty much, arc discharging, melting the ends, and then we get surface tension. It'll bring them together, and your splice complete here. Three of the biggest. Can you guys see that? Are we on the same?
Yep. Criteria mass fusion splice. Yep.
Okay, all right. Yep. Here are our biggest contributors to a good splice. Of course, our cleave angle, and I talked about that earlier. Make sure you have a good cleaver and having good gaps. Like I said, the gap is very important to make sure those fibers are in flat and reference. That's why we have that little press mechanism to make sure that it's in there in the 90s, so we can get all these ends so you don't have one real short and one long, but they're all pretty much pressing in evenly, that we get a good push. Because the machine pushes carriages together, it only pushes them in a distance. It doesn't really care about the shorter fibers. It's just going to be a fixed distance going to push in for the overlap. And of course our axis offsets, and that usually ends up being, like I said, a dirty V-groove. So to make sure that the V-groove's good and you have good axis offsets, and we have another alignment mechanism that'll, like I said, take the clamps up and lower them back down until that they're in specification. But these are the big three contributors to a good splice. And your machine will tell you, we've got inspection criteria built into our programs, that if these are out of spec, it'll throw up a warning, and you can either correct it or ignore it and keep splicing. But we like to, when we train splicers, we'd like to put this is in data output mode on. So it'll come in, it'll stop at this point, and you'll see all this different data. And once you get to recognize what's good and what's bad, it'll make a good splice. Even if the machine doesn't air out, it's very important to have this on, and you can actually stop at that point and re-prep if you have to make sure you get a good result.
Tom, just a quick question. What is a good result for, say, your axis offset? I see fiber 3 is at 2.2, but it still looks like it's passing. What would be a acceptable result or something to be concerned about?
If we're talking about the 124, it has I think it's set up an inspection criteria that when it comes in, it'll go ahead and look at all these. I think it's set to right now either 5 or 7, but and it'll still get really, really good results. But what I like to see personally, I feel comfortable, been doing this for a long time. I like to see under 3s on an axis offset. I like to see my angles under 3s. Gaps, they can vary about 10 microns, but yeah, once you are seeing these, if you can keep these under 3, you can almost predict, as long as your arc check was done properly to set the temperature, you can kind of predict what type of results you're going to get based on this type of criteria. But yeah, if the machine isn't airing out, if I still see them up around 5s, I'm starting to get a little leery at that time, and I might go ahead and reseat the fiber, or you can manually actuate the fiber clamps. Do that a couple times and see if we can get it down a little bit.
Good, thank you.
Okay, key factors, of course, arc power. That has to be done, set up by an arc check. I'm not going to get into this. I asked Eric if I get crazy on the arc check, if he'd stop me. But arc check is very, very important. It sets the temperature, melting the glass. And if you think about it, an arc check, anything that will affect a flame will affect that arc condition, that arc that's being thrown here. You know, humidity, altitude, temperature, of course, all those different things. We recommend doing the static arc check. That's on our opening menu on ours. And I'll tell you why. If you've done a lot of splicing with the ribbon, you know, when you clean the ribbon, you don't get it as clean a lot of times as single fiber. And those little dust specks will actually light up and cause a bright condition. A static arc check, at least for the Fitel machines, goes on a distance, a burn back measurement. On a dynamic, it goes by brightness. And those little those little specks can actually make everything brighter. And the machine will think that maybe the arc condition's too hot and lower it. You'll start getting cold splices. So that's why we really recommend doing an arc check in the morning or in the afternoon if conditions have changed, but at least doing one until they pass at least once a day. It's very important. I mean, to get a good splice, you got to have, it's assumed you'll have a good temperature. That's your arc check, making sure that there's the right current, what we call as a common arc power, that controls that goes through those electrodes, and that sets up the right temperature, and that's done by the arc check. You got to have good alignment. You got to have good fiber preparation by cleaves and cleaning, and a good axis offset, and those are the main ingredients in how to get a good splice. You see some other factors here. Of course, arc power, I talked about that. Arc duration, you know, how long that arc is discharged. The cleaning pre-fuse time, when it actually pre-fuses and starts melting the fibers before we push the fibers together, and the pushing and pulling speed. And then, of course, using a good protection sleeve and the heat shrink into the heater element. This is the 927R in a conventional protection sleeve that I was talking about earlier. I mean, something very small. You don't think it might make a lot of difference, but we've just had a couple 6912s in data centers spliced recently here in Atlanta that we've been helping out on. They've been using our 124, and they started off by using a competitor's splice sleeve, and they started doing the testing. And what they found was several splices, not a lot, but several splices were affected by the splice sleeve. So we ended up taking a bunch of the 927Rs down for them. They purchased this from us, and it made a huge difference. They didn't have any problems after that. But that's all it is right here. This little structure rod, the ceramic member on the conventional, it's flat, and you know, you just shrink down, and you have problems on flat ribbon, regular ribbon, not a big deal. I mean, I'm not telling you to take all your sleeves and throw them out or anything, but on the rollable, you can get a little bit of crossing there, and then it'll shrink down, micro bends, give you a little loss. Up on the 927R, again, we just flip this upside down, and Eric, I don't think we're charging double for those. So, but all we do is flip this thing upside down, and when it melts, it'll come over in an arc also and helps separate the fibers. But something little can really make a big difference. Okay, we'll get into the splicer and the accessories again a little bit more in detail. Pretty much this is everything that a lot that comes in this kit. You know, of course, you got your 124. It can come with the 250 and the 200. You can get it kitted with both, or I think you can get a kit just with the 250. You need the 200 later on. You can buy that separately. Along with that, you got to have the holders. When you have a 200 V-groove, you got to have the 200 holders also to match with it. So there's two sets of holders also that have to go with it. You got to have your 250s for your 250 V-groove, your 200 for your 200 ones. And again, if you're going to get in that situation where you have 250 on one side and 200 on the other, you're still going to have to get into pitch conversions. So we do sell that holder. We sell them in singles, or we sell them in a pair if you need them in a pair. The only time I could see if you needed them in a pair is like if you had our older unit, like the S123, that only had the 250 V-groove. Then you could probably use that if you ran into a 200 to 200 splicing situation. You'd have to pitch both sides out. Is it ideal? No, but you can get the job done. Again, the 200, the 218R plus 200, backwards compatible with different ribbons. 326R, you can still use this on your singles, but it's been optimized for the ribbon fiber. Of course, we have our prep fluid right here in our wipes. Don't take this lightly. I know that I think Eric sells the poly water. That's great, especially when you're doing the ribbon splicing. You've got a real long arc duration. If you're using straight alcohol with that, alcohol likes to standardize there at 80-20 mixture with water. You're going to get a lot of discharge splatter going up on your V-grooves, on your electrodes. Like I said, I am not a microcare salesman, but we have started carrying this, and we got this in a bigger bottle also. It has an anti-static agent in it, which is very, very important for working with, especially with these rollable and pliables, because like I said, they're more loose. They'll want to kind of stick together and maybe cross over each other with the static. This is huge. Don't take this lightly. And of course, it comes with a case, and we have spare electrodes, electrode cleaning disc, and a big V-groove cleaning brush. And that's pretty much, it comes with the kit, and you can get it, you know, pretty much configured with a 200 or 250 or both if you need it. Okay, and going into, and it's just a little bit more with the tools. If you're doing a 250, you know, you can use this holder, of course, a stripper, the cleaning fluid, your 326R, your splicer, and reinforce it with your 927R. And then it gets a little different down here. You'd use everything the same. If you're doing 200, you need these 200 holders. Everything else pretty much the same. But then when you get into the pitch conversion, we're working with Jonard right now. This tool will come out real soon. We're hoping by early July. It's a ribbon separation tool. It doesn't look like much here. Working with our ribbon, Eric, you'll have to try this on the Prismium. If you do have to pitch it out, you need an extra tool here. You can use a brush. I mean, we've seen it advertised just using like a toothbrush, but this tool, it has some Velcro in the jaws here. Usually 3 swipes with that, it's separated, because with doing pitch conversion, you got to take that ribbon, you got to de-ribbonize it, run it into this pitch conversion holder, and then pretty much treat it like any other ribbon. But this tool really helps out a lot, and we should have that, like I said, I'm hoping in July. But very, very helpful little tool to get the at least our rollable ribbon separated. Again, you know, we pretty much went over this. Here's some operating instructions, just basically how to use it, you know, loading it, making sure that the fibers are flat. Here on the heater element, make sure the fibers set between here, they're not crossed over. You know, you wait for it, it'll go red to a blinking green to a solid green, and then slowly pull apart with good pressure on it. And again, brushing out the coating. This adds a little bit of time, not much, but just brushing out that coating on your blades here and up here to make sure it's clean before each strip, or you'll double blades or it won't strip really well. That's what adds a little bit of time, you know, to doing the rollable compared to like 255. To 326R, again, same thing when we're using the thing, make sure the fibers, I don't have a picture of it with the pads, make sure that the fibers aren't crossing over each other, that they go across both pads, laying on top of the exit roller, and that's pretty much it. It's pretty much a one-step type of cleaver that we have. Okay, here's a better picture of what's going on with conversion. If you see the way this thing is designed, this is all still in 200 pitch. So you'd strip out about, I don't know, I think it's 45, 50 millimeters worth of fiber. You take this tool here, separate it out, and then you have the fiber off the end, you start pulling it back, and you anchor the 200 still in the 200 pitch where it's still adhered. You anchor that with that first door. And then with your thumb, you start working the fiber out into that pitch. And once you get it worked in there, and this is a pretty quick operation. It doesn't take a lot of skill, just a little bit of practice. Then you lock it down behind yourself, and then you roll it out here, do a slight bend over the edge, and lock it out. And then you go ahead and treat that fiber like it was, you know, the 200 rollable or 250 rollable. You know, you strip it, clean it, cleave it, load it in the machine. But very, very handy to have you run into that type of situation. This goes over the complete operation for that. You know, this you're going to use to de-ribbonize it, setting them in again with the 200 pitch right here's non-split portion, anchor it, then you use your thumb, start rolling it out, you know, pushing it out into those V grooves, anchor it while you go until you get to the end, and then you do a little bend and cover then your last lid, you cover it up, and then you've got it in the pitch. You can hold it up at a light, and you can pretty much see that you've got a good pitch and everything's even. This operation, you know, if you mess up or what, maybe a minute, maybe, but it does add a little time onto the whole situation. These guys that were in Atlanta were actually going to take their 70 Rs that they had, their AFLs, and they were really good at doing pitch conversion. They've been doing this a lot. They were going to convert or pitch conversion all those 200s to 250 and use their AFLs. We came down there, we introduced this to them, and they decided to go with the 124 so they could do, you know, just the 200 to 200. Okay, this pretty much says it all, guys, for the Fitels. Is, you know, you're going to either buy, you know, going forward, you buy two old type of machines. If your manufacturer offers it in a 200, I think Sumitomo does. Again, AFL I don't believe does. I don't know if any other manufacturers, but you'd buy two Sumitomos. You buy one for 250 and you buy one for 200, or you can buy one S124 M12 Fitel with exchangeable V grooves. I mean, that pretty much just says it all, and that's why this machine was developed. And I always forget, Eric, when I'm talking about these machines. Again, like I mentioned earlier with the Ninja and the 179, I keep on talking about this for, you know, for the different pitches. When you take that V groove out, your lenses, you guys can see my pointer here, your lens is set right here and here. When you need to clean the optics on this thing, when that V groove comes out, they are so easy to clean. This machine is so easy to maintain that unless this thing is dropped or someone damaged the lenses by not cleaning them correctly, this shouldn't have to come back to my lab. Everybody asked that about calibration. Should I send that in every year? I said your calibration is a reflection of your OTR shoots. If this thing is giving you good estimated loss, good actual loss with your OTDR and functioning properly, you don't have to spend those maintenance dollars and shipping dollars and downtime to ship that to me. Keep the thing out in the field, maintain it properly, easily maintain it properly, and you're good to go.
Don't forget to arc check.
Don't forget the arc check. But like I said, it's industry first, patented field replaceable V groove, can easily be changed, work with 200, 250, 16 fiber coming soon, and 80 micron coming soon. We've got a touch screen. Our earliest machine that had the touch screen was the 179. We have a touch screen on this one, fast heater cycles. We've got a little app, Wi-Fi communication between the machine and the Fitel Smart app that you can update the software on it. You can download results. But the biggest thing for us is very easy for our customers to go ahead and be able to update any type of software. It takes seconds instead of minutes, and you don't have to hook it to a PC. And of course, here's the different fibers it can handle right now: the flat, 200, 250, rollable, 200 and 250. And this is a better look at the V grooves here down the bottom right-hand corner. Some of these other tools that are just, of course, you've seen the stripper and the cleaver, but this is a 220A used for flat ribbon, 250. It actually shaves it, so if you need to separate it, you shave a portion on the end and separate it. And with flat ribbon, this is our 233. You can get different blades for it. You can split like 24s into 212s and 4 and 8, and there's different blades that you can buy for that. But that's just a couple other items that we sell for the complete ribbon splicing solution. I won't go through a lot of this. You can have this for reference. This was actually used for another training that we had. I thought we just include it in here, just showing our basic operation, our keys. And if you have one of our machines, you ever call in the service, talk to myself or my coworker, Andrew DeGidio. We always tell you to go from the ready screen. That's like the main splicing screen. We always start from that point. But this is just the different buttons. Very easy to select your splice program, your heater program. Heater key, it'll start automatically. And I think they come from the factory. It starts automatically when the heater is closed. It has a little micro switch up near a heater clamp. It starts automatically for you, so you don't have to hit the heater switch. And just the start key. Again, you can configure that in the settings where as soon as the windshield closes, if the machine doesn't see any type of errors at all, it'll just go on with the splice until it's complete. Like again, to select your programs, it's just you can either do it from the touch key or you can do it from the control panel. Select your different programs. Same thing with your heater programs here. Very easy to use. Arc check. We went over this kind of in detail already, but again, it's going ahead. It sets up your common arc power and the current that goes between these two electrodes. And again, it's affected by dirty electrodes. Make sure your electrodes are clean. Ours is capable of cleaning our unit with electrode cleaning disc that we include with the kit. But any type of condition, dirty electrodes, temperature, altitude, humidity, anything that will affect the flame, make sure we're doing it. If we can get everybody to do this at least once a day in the morning, I'd be very happy. If you got some type of environmental condition changes, do it again in the afternoon or whenever that happens to keep your splices good. Low loss. And these are just some of the different settings. I talked about data output earlier on when we've seen those screens for cleave, gap, and axis offset. We could see all that because I had this turned on here, data output on. So that's what we do. Again, clamp up and down. That's an automatic setting. You can turn it off and do it manually, but I think it comes configured automatically. You turn that on. If the machine sees a high axis offset, it'll automatically on its own start raising those clamps off and lowering them, trying to get the axis offsets down. That's a couple of major ones there. And we'll quickly go through the splicing operation here. Just pretty much, doing the rollable, placing it in the holder, making sure everything is good and flat. Then using the stripper, taking it, putting it into the stripper. Again, you see the Q-tip here. If it is crossed over, make sure it's flat. After the strip, make sure we're cleaning that out, that coating out. We're using fiber prep fluid here, making sure that the fibers don't overlap and they're squeaky clean. And then cleaving, again, making sure that the fibers aren't overlapping and sitting on top of each other. That will mess up the gap and possibly the cleave angles. Placing them into the machine, making sure they're all in the V grooves. They're not jumped out of the V grooves. And you see the earlier picture, I think it didn't have the 200 holders, but very easily to distinguish the P200 holders, they have it right here for 200 micron. And of course, putting our protection sleeve on, centering the sleeve over the splice point, and then centering the whole sleeve and the splice point, centering it into the heater. And guys, I want to just finish up with our website. You can get a lot of information here that you'll have this. All of our different splicers tools and accessories and SS Solutions, one of our premier distributors, and they carry all of our products. We've got instructional videos out there that are very helpful. A lot of the things that we just talked about, and also with our single splicers, our SOCs, technical support, contact information, how to get a hold of us, how to create an RMA in case you need to get in the system and send your machine in. But that pretty much concludes the training for today. I'm right at about getting close to 45 minutes. I know we want to do some questions and answers. So Eric?
Yeah, if there's anyone that has any questions, feel free to post them in the chat box, or and then I could unmute you. Actually, we can go up that way.
I hope this covered a lot of things and a lot of questions maybe you had about a rollable ribbon, pliable ribbon, spider, and all that. It's definitely a different game out there from 3 years ago when everything was just flat. So just wanted you to be aware of the different tools and compatibility issues when you're going out to splice this type of ribbon.
Thank you, Tom. Very informative. Definitely excited to see some of the pitch conversion tools and the process that Fitel is using for that the 200 to 250 seems to be getting a lot of questions. Jeff's asking, what's the typical battery life on a 4 charge, and then are spare batteries available?
Absolutely. The battery is inside. You can take it out. I think we got on a fully charged battery. It's 180, I believe. Full cycles with both splicing and heating. And
does this one have 2 battery bays like the 123?
No, it just has one. But one nice thing that a lot of our AFL splicers out there really like about our machine is you can actually charge this while you're working with it on the AC adapter. So that's a little benefit. They seem to like that really well.
Yeah. And are spare batteries available if needed?
Oh, absolutely. Yeah. You can separately.
Okay. Kelly's asking, how difficult is it to break out a single fiber once it's spliced into the ribbon?
That's what everybody really likes about this, because there's really no good way to do this, right? We've seen people try to take that 220 tool that I showed you earlier, that shaver, pretty much, it shaves the matrix off. And man, people will do it. I mean, they'll if you got to get a job done, they'll do it. Not recommended, but if you have a chance, if Eric can show you or get you a piece of this rollable ribbon or prismium ribbon, it's very easy to separate out and get that one fiber out. I mean, really no tools required. Just fan it out, and you can get that fiber out to break it out.
Does that answer your question, Kelly?
Eric, I'm sure the prismium is the same way. And as far as how it trays, it doesn't have that memory like the flat does. It's a lot easier to tray.
Yeah, that's one of the big advantages I know a lot of folks really like, is it's a lot easier to manage the rollable. Well, any other questions from folks out there? All right. Well, we're going to go ahead and close up here, but Tom, really appreciate the presentation. Really like to see what's going on with the 124. Can't wait to get my hands on one. So if there's any other questions from any folks, please. What is the current lead time for the 124?
We've got them in stock right now.
That's what I thought. Yeah, they are available now. Correct.
Full kits. The only thing that isn't available, like I said, was that ribbon separator tool, but you can use a brush to brush that out to separate it in the meantime. But that's for the 200 to 250 transition.
Perfect. All righty. Thank you, everyone. And thanks especially Tom. You guys have a good rest of your day, and we'll see you next week on Wednesday.
Appreciate it. Thank you.
Thanks, Eric.